Okay, so this video is over linear functions, an Algebra 1 skill that we've reviewed before in semester 1, but it is the simplest of polynomials is a linear function. Now what we were working in class on a quadratic function, that is the second simplest function. So I want to go back over linear functions with you though one more time here with this video just to ensure that you have it down. Now linear functions, as you know, have a constant slope. The slope doesn't change, it stays the same. A linear line, the slope stays the same. It isn't like it changes. Like with the quadratic, it comes in and makes a u, and with those polynomials we've seen, it even makes many terms. So, first example, positive slope. And we all know that positive slope goes up from left to right. We also have negative slope, which comes down from left to right. An example of an equation with positive slope, y equals 3/4 x. This one has a y-intercept down here, so I'm going to write -5. An example of negative slope, y equals -2/3 x, and it hits up here, +6. It would be entirely possible, though, for this to hit down in the negative realm and still come through with a negative slope. The other two types of slope are a zero slope, which comes across horizontally, and the y value stays the same here. That's why we have y equals, maybe it's 4 high all the time. This would be the point 0, 4, 1, 4, 2, 4. The y value is always 4. And the last example, undefined, goes straight up and down. And an example would be x equals -5. So the x value is always -5 on this line, no matter how high up and down I go. Now there are three forms that we know for writing linear equations. One is slope-intercept. It is y equals mx plus b, where m represents the slope and b represents the y-intercept. The other one is point slope, and that looks like y minus y1 equals m times x minus x1. Sometimes I'll put this over here in parentheses, sometimes not. And the last one is standard form. ax plus by equals c, where a is positive, not a negative, and no fractions. No decimals for that matter either. So a lot of times we'll clear the fractions out to write something in standard form. Each of these forms has uses that we've gone through. This one is probably the widest used. So, on the back side, here's an example. Let me zoom in a little. And we want the equation of the line that goes through the point 6, 1 and -12, 13. The first thing you should do anytime you get something like this is draw a picture of it. It doesn't have to be a great picture, but if I go over 6 up 1 and back 12 up 13, it does two things for me. The line that goes through here must have a negative slope, I can see. And the y-intercept has to be around here. It has to be higher than a y value of 1 and less than a y value of 13. So if I do the math and it comes out that my y-intercept is -8, I know that I've made a mistake. I'm going to guess that maybe it's +5 or something. So we can estimate the y-intercept. That's the power of drawing a picture there. Now, if I do my slope wrong when I'm calculating it and I get a positive slope, I'll know that I did it wrong. So when I'm calculating the slope, I get the slope equals the change in y, 13 minus 1, over the change in x, negative 12 minus 6. That gives me 13 minus 1 is 12, negative 6 minus, well, negative 12 minus 6, negative 18. If I would have went 1 minus 13 on top, then I would have had to do negative 6 minus a negative 12 on bottom. And that would give me the same answer when I reduce this. So I see that 6 goes into both of these, so I'll reduce, divide by 6 here gives me 2, divide by 6 here gives me a negative 3, and the slope formula automatically puts the sign on there for you. Some people would rather do it x, y, make a chart. Another way of doing it, 6, 1, negative 12, 13, and find the difference in the y's and the difference in the x's. From 1 to 13 is 12, and from 6 to negative 12 is 18, a difference of 18. So the slope would be 12 over 18, and you have to think about it then in order to ensure that you put the negative sign on for the negative slope. And then we're right back to the same thing. Other people like to count the slope, and they say how far down does it go versus how far over does it go. And from this y-coordinate of 13 to this y-coordinate of 1, that's a drop of 12. And from 6 to negative 12, from 6 to negative 12, that's a total distance of, here's 6, there's 12 more, 18. So again, I would get the change in y over the change in x is 12 over 18. I have to consider that it's definitely a negative slope. So far I have then y equals negative 2/3 x plus b. I prefer using slope-intercept form. If you like point-slope form, there are definitely different ways to get the answer to this. But at this point, I'm going to take 6, 1 and plug that point in. I could have chosen this point, but this looks like nicer numbers. I know that when x is 6, y must be 1. I'm using the point 6, 1. The reason I'm doing that is because there are a lot of different lines with the slope of negative 2/3. They're all parallel to each other. But I lock it in when I grab this point and make it go through there. Again, when y equals 1, x will be 6 for the line I want. And I can find out what y value or what b value will do that. 6 times a negative 2 is a negative 12. Divided by 3 is a negative 4. 1 equals a negative 4 plus b. I add 4 to both sides. B equals 5. I look here and it makes sense that 5 is at least reasonable. So slope-intercept form, y equals negative 2/3 x plus 5. Standard form, I'm going to do the work in this leftover area. So I'm going from slope-intercept form, SI form, to standard form. In order to do that, I write y equals negative 2/3 x plus 5. And I know I can't have any fractions, so I'm going to multiply everything by 3 to clear those fractions out. 3 times y is 3y. 3 cancels with this 3, giving me negative 2x. 3 times 5, 15. When I add 2x to both sides, I get 2x plus 3y equals 15. And that is standard form. Second example. So first we're going to find the slope. First we're going to graph it actually. 3, 9 is about there. Negative 2, negative 11 is about there. Now ideally you would pause the video at this point, See if you can write the equation by yourself and then verify it by what I do. So I do ask you at this point to pause the video and try it first. Okay, hopefully you paused the video. Writing the equation of the line between these 2 points. It's not a great graph, so I can't tell whether it's above or below the axis, but I do know that the y-intercept is in between -11 and 9, somewhere in there. That's the interval that it must be on. Probably closer to somewhere in between -3 and 3. I do know that it has a positive slope. There's no doubt in my mind about that. So the slope, I'm going to do 9 minus a -11 over 3 minus a -2. Now minus a negative is plus a positive, and minus a negative is plus a positive. So we get 9 plus 11, that gives 20, and 3 plus 2, 6. That reduces to 10 over 3. So I'm looking at y equals mx plus b. That is 10/3 x plus b. So we have y equals 10/3 x plus b, and we want the y-intercept. I need to find that. I'm going to lock it in here by putting in 3, 9. When x is 3, y has to be 9. I avoided that one there, didn't I? 9 equals 10/3. Oh, this is going to work out great because the 3's are going to cancel. Plus b. And the 3's will cancel. 9 equals some number plus b. Well, I could subtract 10. You could probably think about 10 and some number equals 9. I got to take 1 away, so b is a -1. Or I can do minus 10 minus 10, still gives me b equals -1. So we have y equals 10/3 x minus 1. Y equals 10/3 x minus 1. You might not want to write it like I did there. It's a little sloppy. To change this into standard form now, I'm going to multiply by 3. I don't want you thinking you always multiply by 3. I pick the denominator, and that's what it gets multiplied by. So when I multiply by 3, I get 3y equals, the 3's cancel out, 10x minus 3. Subtracting 10x from both sides, I get minus 10x plus 3y equals -3. And if we ever work accelerated math accepts this as standard form, as do some books. But we have the rule that we've been using that says the a value cannot be negative, so we multiply 3 by -1, which then gives us a positive a value, minus 3y equals 3. 10x minus 3y equals 3. Now this equation and this equation are equivalent to each other, just different forms. If I plug in x equals a number here and find out what y is, it better be exactly the same as plugging a number in here and finding out what y is. So, down towards the bottom now, a linear application on temperature conversion. Where is this used? Well, this is an equation to convert from Fahrenheit to Celsius. So first of all, if Celsius is 10, what is F? Well, that means plug 10 in. 9/5 times 10 plus 32. So F equals, I could do 10 times 9 is 90 divided by 5. I would rather do 10 divided by 5 first is 2, and 2 times 9 is 18. Either way, though, should get you the same result, plus 32. So I guess that's 8 and 2 is 10. Carry the 1, 3, 4, 50. That means 10 degrees Celsius is the same as 50 degrees Fahrenheit. Over here, solve for C. And over here, if F is 45, what is C? They're both numbered number 2. Sometimes these worksheets do that to me. So I have to choose which one I'm going to do first. First of all, if F is 45, what is C? I would have to plug 45 in here and then solve for C. If I already solve for C, I'll have an equation that I can plug into. So I'm going to do this one first. If I solve for C, I want to get C by itself. So I'm going to F equals 9/5 C plus 32. Subtract 32 from both sides. That gives me F minus 32 equals 9/5 C. Now I want to get rid of this 9/5. I can either multiply by 5 first to clear that 5 out, or I can get the C all by itself by multiplying by the reciprocal 5/9, and that way on top 9 times 5 is 45, 5 times 9 is 45. When I divide, I get 1. Or the 9's cancel out, the 5's cancel out. When I cancel them out, I get 1. So I just get C over here. If I multiply this side by 5/9, I have to multiply this side by 5/9, the entire thing. Which gives me 5/9 F minus, let's see, I need 32 times 5/9. I'm going to go ahead and pull up the calculator here, and 32 times 5 divided by 9 gives me 17.7. Try it one more time to make sure. 32 times 5 divided by 9 is 17.7. Now I could write it out like this, but maybe it's better even just to keep this 5/9 on the outside here. I'm going to do that when I write it down here. Celsius equals 5/9 times the Fahrenheit minus 32. And that way, if I want to know when Fahrenheit is 45, I can just plug it in right here and not deal with this sort of odd decimal. So when I plug 45 in for F, I get C equals 5/9 times 45 minus 32. Up here. 45 minus 32, I guess that's 13. So I get 5/9 times 13. And again, I'm going to pop the calculator because I don't want to do it by hand. 5 times 13 divided by 9 is about, I get 7.2. So if I've done that correctly, 7.2 degrees Celsius is the same as 45 degrees Fahrenheit. And you know we have Google, so you can just type into Google 45 degrees Fahrenheit, and it should come up to be about 7.2 degrees Celsius. Last question. If F is 32, what is C? So I have the equation C, if I want to know what that is 5/9 F minus 32. And when I put 32 in for F, 32 minus 32 is 0. 5/9 times 0 gives me 0. You probably already knew that. You probably already knew that freezing is 0 degrees Celsius, 32 degrees Fahrenheit. So that sort of makes sense to me. Makes me feel like I have the equation right too. Thanks. See you in class.